Hello, my name is Mai. I'm going to present how we combine intrinsic motivation with transfer learning so that robots can discover and exploit task hierarchy to use in open-ended multitask learning. So let us consider a setup like this one, where we have a 7 degree of freedom arm that can move around with action primitives. And it can do various effects on its environment. For instance, here it can move the blue um, object by reaching the object and then pushing it. The same goes for the green object. And he can also compose the positions of blue and green objects, which means that then he can use the actions that he used for each of the subtasks. So it would mean a compound action of 4 primitive actions. And because if it's a DJ table, he can also use these buttons to create music, some burst sounds or some more sustained sounds. The question is, how can he transfer his knowledge from simple tasks to more complex tasks when he doesn't know even about the dependencies and hierarchy of tasks? We showed in simulation and on a physical robot how a robotic arm can learn its motor control to reach a simple point for a simple task like this, or to execute more complex tasks. Here it had to discover and learn what the subtasks are and which policies to use for each subtask. So to make a sustained node, we decompose it in 5 subtasks. So to move the blue and the green object, which then makes a burst sound, and then he pushes another button to make a more sustained note. Is about learning compound actions using task hierarchy. In multitask learning, we want the robot to be able to propose policies of different complexities using compound actions, as Justus Pieter named them. For us, it's sequences of primitive actions of adapted size, adapted to the complexity of the actions. And for that, we hypothesize that some tasks are related to each other and they are hierarchical. And the robot needs to discover and exploit this hierarchy. So we propose a task-oriented representation of this combination of skills and propose a SJMPB algorithm, socially guided intrinsic motivation with procedure babbling. So our contributions are first that we propose a representation, a new representation called procedures, that is a goal-oriented representation of compound actions. The second contribution is in hierarchical reinforcement learning, where we show that our procedures enable the online discovery of task hierarchy for exploitation in a hierarchical ways. Because it allows transfer of knowledge from easy tasks to complex tasks. The third contribution is in terms of curriculum learning. We propose the algorithm SJMPB for socially guided intrinsic motivation with procedure babbling that was able to determine itself its automatic curriculum by choosing first easy tasks before moving to complex tasks, and also by first exploring the action space before exploring the procedure space. In terms of human demonstrations, imitations learning, we show that the demonstrations can bootstrap the learning best when they show demonstrations of policies for the simplest task, and if they are demonstrations of procedures for the highest hierarchical and complex task. Our algorithm, SJMPB, was able to determine for active imitation learning what, when, how, and whom to imitate by itself. In terms of transfer learning, we also explored the case of cross-task transfer learning that was bootstrapped and enabled by the task decomposition that we use through the procedures. And we also explored cross-learner transfer learning from expert demonstrators, but also from other robots. And we showed that we can efficiently transfer procedures better than policies, actions by themselves, and that it's even more effective when it's about active imitation, when the learner can select the way the information is transferred. So our algorithm was able to determine what kind of information, when and how to transfer the information, but also which source of information is best. Thank you for your attention. These are the references and the article citation.